Hello students, today let us see the focal property of an ellipse and one of its application of the property. The concept is related to ellipse. This is focal property. What it means? The sum of focal distances of any point on the ellipse is equal to its length of major axis. This is focal property. So, what is focal distance? Focal distance of a point means the distance from focus to any point on the ellipse. That is called focal distance of point on the ellipse. There are two foci to the ellipse. So there exists two focal distances for every point on the ellipse. Their sum is always equal to some constant that is equal to the length of the major axis. You are going to show that. That is, the sum of the focal distances of any point on the ellipse is equal to length of its major axis. How to prove this one? Let us see. Consider this is x-axis. It is y-axis. Consider the ellipse x square by a square plus y square by b square is equal to 1, a greater than b. Their foci are, one is S and other one is S dash. Its midpoint is center of the ellipse C. A is the vertex of the ellipse and A dash is the another vertex of the ellipse as shown in the figure. Their directrix are L and L dash respectively. They intersect the x-axis at Z and Z dash as shown in the figure. This is the ellipse. Now, let P be any point on the ellipse whose foci are S and S dash. Now, we have to prove that SP plus S dash P is equals to 2A. That is your claim. What is P? Which is any point on the ellipse. What are their foci? S and S dash. What is the focal distance of P with respect to the ellipse? One is SP and other one is S dash P. Focal distance means the distance from focus to the point P. So, this is my any point P on the ellipse. Join SP and join S dash P as shown in the figure. What you have to show? Their sum of the distances is equals to the length of the major axis. Length of the major axis means the distance from here to here, that is AA dash. So this is SP, this is S dash P. So their sum is always, you have to show that AA dash, that is 2A. If you take P here, you can also prove that S dash P plus SP is the same as AA dash. It is your claim. For this, draw two perpendiculars from P to the corresponding directrix as shown in the figure. This is PM is one perpendicular drawn from P to the first directrix. Similarly, draw another perpendicular from same point P to the second directrix, that is PM dash. PM and PM dash are perpendiculars drawn from P to the directrix. One is PM, other one is PM dash. What is the definition of the conic? SP by PM is equals to E, then the locus of P is conic. So SP by PM is always constant, that is equal to the eccentricity of the conic. Here what is our conic? Ellipse. Therefore, by definition of the ellipse itself, SP by PM is equal to E as well as S dash P by PM dash is also equal to E. So by definition of the ellipse or conic, SP by PM as well as S dash P by Pm dash is equals to E. So Sp is equals to E into Pm, S dash P is equals to E into Pm dash on by cross multiplication. What you have to do? You want Sp plus S dash P. That is why you just add the equations 1 and 2. What will happen? Sp plus S dash P is equals to E will be common Pm plus Pm dash. See here, this is Pm. This is Pm dash. What is Pm plus Pm dash? That is nothing but mm dash. Pm plus Pm dash is mm dash. That is E into mm dash. Now from figure, what is mm dash? Mm dash is nothing but zz dash. The distance between the two parallel lines is always same. So the two directrix are parallel. Therefore the parallel distance is always same. That is why mm dash is equals to zz dash. This is nothing but E into zz dash. So that is equals to E into 2a by E. What is zz dash? This is nothing but 2 times of cz. C is midpoint of zz dash. Therefore that is 2 times of cz. What is cz? Distance from center to the directrix. What is the equation of directrix in the standard form? X equal to a by e. So the distance from origin to x equal to a by e is what? A by e. So that is nothing but 2 times of a by e. 2 times of a by e. Sp plus S dash P is equals to 2 times of a by e. E gets cancelled. That is why you have 2a. Therefore Sp plus S dash P is equals to 2a. Hence proved. That is the sum of the focal distances of any point on the ellipse is always constant, and the constant value is equal to length of its major axis. What is the major axis of ellipse? X square by a square plus y square by b square equal to 1, 2a. Therefore Sp plus S dash P is equals to 2a. P is any point you take at any place on the ellipse. Sp plus S dash P is always constant to its length of the major axis. Okay. Now let us see one application on this one. This is the problem. See here. 2 circles are given such that one is completely inside of the other without touching each other. How many circles are given to you? 2 circles are given to you. One is completely inside of the other. They do not touch each other. Then what you have to do? We have to prove that the locus of center of a variable circle, the locus of center of variable circle which touches the smaller circle from the outside and bigger circle from the inside is an ellipse. This is your target. 2 circles are given to you. One is completely inside of the other. They are fixed circles. They do not touch each other. What you are going to prove? The locus of center of circle. What is the role of the circle here? Each circle touches the smaller circle from outside and bigger circle from inside is an ellipse. It is an ellipse. We have to find out the locus of the center of circle which touches the smaller circle from the outside, that is externally, bigger circle from the inside, that is internally, is an ellipse. That is the given thing. You have to show that the locus of the moving point, that is the center of the circle, is an ellipse. Further, let C be the center of circle, R be the corresponding radius of the circle. Say, let C be the center and R be the radius of the circle which touches the circle with the center at C1 and radius R1 internally. So this is the largest circle. The circle having center at C1 and radius R1 is the largest circle and touches the circle. This is the smallest circle which is inside of the circle C1 with circle center at C1 and radius R1. This is C2, radius R2 externally. What I am taking here, C be the center of circle and R be the radius of circle which touches the circle with centered at C1 and radius R1 internally, and the other circle having center at C2 and radius R2 as externally. Let us see the figure. This is my largest circle having center at C1 and radius R1. Listen carefully. This is the center C1 and its radius is R1. There is another fixed circle to you. This is my second fixed circle. It doesn't intersect the given first circle, and second circle is completely inside of the first circle. So its center is C2 and its radius is R2. These are my given two fixed circles. Now what is the question here? You have to find out the locus of center of circles which touches the largest circle internally and smallest circle externally is an ellipse. Let us see one of such type of circle. Observe clearly. This is the circle which touches the largest circle externally and smallest circle externally, largest circle internally. Okay. This is the center of the circle. C is the center of circle which touches the circle having center at C1 and radius R1 as internally, and touches externally the circle with center at C2 and radius R2 as shown in the figure. So this is the center of circle. You are going to find out the locus of the center of the circle. This is circle. It touches what? Touches the internally the largest circle, and this touches externally the smallest circle. So how many circles can you draw in this manner? You can draw infinite number of circles such a way that the circle touches the largest circle internally and smallest circle externally. I am showing one more circle to you. This is also another circle. Touches your largest circle with center at C1 and radius R1 internally, and touches the circle with center at C2, radius R2 as externally. I am going to show one more circle to you. This is its corresponding center. This is the third circle. The role is same. It touches the largest circle internally and it touches the smallest circle, that is the second fixed circle, externally. This is its corresponding center. You collect all these centers, you get some locus, that is you have to show that an ellipse. So from this concept, what you have? This is C1, fixed center. This is C2, fixed center of the another circle. This C is varying like this. So the locus is, you have to show that an ellipse. So from this figure, we have some conditions. What is the distance from C1 to C2? Here the circle having center at C1 and center at C2 are touch each other internally. When you are saying two circles touch each other internally, C1 C2 is equals to modulus of R1 minus R2. R1 is the radius of the first circle, largest circle. R2 is the radius of the smaller circle. Here what is the radius? Here this is the circle having center at C is R. The radius of the circle having center at C1 is R1. So the distance from C1 to C is what? The distance from C1 to C is R1 minus R. Because the distance from C1 to here is what? R1. The distance from here to here is what? R. So the distance from C1 to C is R1 minus R. Similarly, the two circles, one is fixed circle, this is my variable circle, touch each other externally. So the distance from here to here is what? C to C2 is what? That is R2 plus what? R. Two circles touch each other externally. What is the condition? Distance between their centers is equal to sum of their radius. So C to C is equals to R plus R2. C1C is equals to R1 minus R. I am going to write these two equations. C1C is equals to R1 minus R. Similarly, we have C2C is equal to R plus R2. These are two equations. Clearly observe that what are and R1 and R2s, they are two fixed values. What is R? Varying. So how to eliminate that variable value? Just by adding these two equations. By adding these two equations, what you have, C1 plus C2 is equals to R1 plus R2. Is it constant or not? R1 plus R2 is constant. Observe the left side. What is C1? Fixed point. What is C2? Another fixed point. What is C? Variable point. This is of the form SP plus S dash P is equals to some constant. What is our focal property? Sum of the focal distances is constant. That is equal to length of the major axis. Here our C1 and C2 roles as foci and C is point on the ellipse. Now clearly C, C1, C2 are not collinear. Observe here, if they are collinear, the locus of C becomes line segment. Here note that C1, C and C2 forms a triangle. That is why you get clearly an ellipse. So the locus of C is what? An ellipse by using the focal property. So by using the focal property, locus of C is an ellipse. See the wonderful question. There are two circles. One is the largest circle and other one is the smallest circle, which is completely inside of the circle and doesn't touches the given first circle. Then the locus of center of circle, which touches the largest circle internally and touches smallest circle externally, is an ellipse. So the locus is an ellipse. It is a problem solved by using the property focal property. So by focal property itself, the locus of C is an ellipse. Now let us see how is the locus. This is my locus. The locus of center of circle which touches the larger circle internally and smaller circle externally is an ellipse. Let us see once again. This is my locus. Okay. So the required locus is an ellipse. It is proved by using the focal property. Thank you.